BD5 Pilot with you at the Hillsboro Hangar, and I told you I'd have some changes to talk about this weekend. And those changes are going to take place here in this engine bay. So since February, when I put it on order, I've had a Hirth engine on order. It's a 3-cylinder, 2-stroke, water-cooled engine. Weighs 108 pounds in its dry state, but I still got to put cooling fluid, got to deal with all the other components that go with that engine and get it mounted, and put a radiator on the aircraft, and of course that included a scoop that would fit under the belly that I selected that would be a very low drag system. And I figured all around I'd probably have 125 pounds, maybe a little bit more, into that entire installation to make that engine work. It would have 84 horsepower. I may end up with an aircraft that weighed 430, 440 pounds, all said and done. Well, in the waiting period of the Hirth having some difficulty with getting those components, I started looking at some other engine combinations. I posted a video talking about some of my crazy ideas, some radial RC engines, which would have been fun, but I didn't find a good match, and most of those manufacturers don't want to sell for human-powered applications. But I came across an engine made by a company in the Czech Republic named ZDZ, and they do make RC engines, but they also make engines for powered gliders, powered parachutes, and ultralights in Europe. And they had a very, very interesting engine. Now, this engine changes all kinds of parameters for this aircraft because it weighs 32 pounds with the starter. And the dimensions on the engine, 14.5 inches wide, 12.5 inches long, 10.5 inches high. It will fit into that engine compartment with really no difficulties at all. I can maintain the on the side covers. I planned on using the little shark tooth louvers, which Aaron Oswald used in his design. That would be an excellent system for exiting the air with a zero drag on this airframe. What I do have to put in, though, are the NACA ducts like the jets use to bring the air intake into that area, and that will serve for cooling this engine compartment. The component I'm going to have to do, I'm going to have to do another scoop, except that scoop is going to go down here to the rear. And it's a scoop that was used in the second prototype, November 502 Bravo Delta, the second prototype BD5. Had a P-51 style scoop design. It was for the air intake, the cold air intake, to force air into the Zenoa engine that they had outlined for that particular aircraft. And that's the same system I'm going to use on this. I'm going to use a forced air intake from the air pressure when I'm in flight through that scoop, and the carburetors mount on the bottom of that particular engine, so it actually works out perfect. In fact, everything about that engine is working out ideal for fitment, for mufflers, for intake system, for weight and balance of the aircraft, and in all likelihood, I'm going to have an aircraft that in completed form is 330 to 340 pounds. That changes my stall characteristics, and even though it's a 50 horsepower engine, with that light weight, I'm probably going to experience very close to similar cruise speeds, and we're just going to have to watch what the development holds for us as I get that engine in the next 3 to 6 weeks and start doing the installation. So there you have it. That will be the next set of work I'll be doing on the aircraft, and I'll keep you posted, let you know when I'm getting the engine, and probably show some uncrating pictures of that. So BD5 Pilot out for now.